Hey guys, my name is Kaustubh. You can call me K. And in these videos, I'll be covering up the course content for CKA, which is Certified Kubernetes Administrator. There is an understanding that one needs to have a background on Docker, which I am assuming over here that you already are aware of. But in case you don't have knowledge on Dockers, then I request you to have a look of my videos on Docker. So what all we gonna cover up in CKA is about the entire course curriculum, which is mentioned over here. What exactly is Kubernetes? The short form is K8. What are the workloads and scheduling? How does networking work? What is the storage? And how do we troubleshoot that? Everything you can find it over here. Okay, so quickly, I'll just run through about what CKA is, what is the background behind it, and then we'll just do the hands-on. The first chapter, I call it intro. It talks about what are the containers, what is a container engine, and what are container runtimes. So container, as you know, it's kind of a virtual machine. It exists on a same physical machine or physical host, and it's much faster because it doesn't carries the entire operating system, I would say. And so the boot time is much faster. You can run applications on top of it. Uh, but how do they run? It requires a runtime, a program. So container engine, it's more of a general software platform. So one of the software platform is called Docker. Others are Cryo, which is by Red Hat, and as you can see, RXT and LXT are others. So just like an hypervisor, which gives you a platform to run your virtual machines. So, sorry, this is a container, not a runtime, which is also called as a container engine. Now, you need a runtime, which is a low-level component. Also, it's think of it like a program uh, of the container engine, which actually mounts the container and it works with the operating system, which is usually a Linux-based operating system, which supports the containerization process. So that's about what exactly are a container, what is the engine, and what exactly is a runtime. Um, K8 Kubernetes. So if you quickly go through Kubernetes, that's the website, kubernetes.io, and it's an open source product. Um, that's why we have cloud-based enterprise Kubernetes products. Oracle has its own Kubernetes product. Red Hat OpenShift is from Red Hat. VMware has Tanzu, SUSE Ranch, or Amazon has its own with a different naming convention. But overall, the concept is same. Containers actually puts an enormous value on orchestration. It gives you the feature called orchestration. Um, and it vitally relies on products like Kubernetes to automate and manage the entire containerized environment. Um, so it actually handles the array of container images and especially the pods and clusters. For the time being, let's call pods as containers. So Kubernetes gives you an interface which is called Kubernetes Container Runtime Interface, which is nothing but an API that actually lets you talk to the container runtimes. And the container runtime interface, which is CRI, is the main protocol for the communication between container runtime and kubelet. We'll come back to kubelet what that is. But standardization is the main reason why we have Kubernetes. So if you read this part which says Docker was actually picking up the market, but the only problem was just like, for example, if you know that there is a standalone host and there is a host which is part of the domain, that's where the reason for Kubernetes came into the picture. So in 2015, with the release of Kubernetes, container runtime interface came in, and it actually lets you manage all the container engines. Challenges with Docker was there was no centralized management. Features like high availability was not there, scalability was not there. Advantages, whatever the challenges with Docker was, that's an advantage. Um, Docker hosts can now be added to the Kubernetes for management. Any action related to the containers are taken care at the Kubernetes server, which is actually called the master server. It maintains the Docker host and its state. A high availability feature like if Docker host fails, the container running on it will be moved to the host 2, which is part of the cluster. Versioning is another feature of Kubernetes, rollout and rollback app versioning with zero downtime, and you can have user base access control. Now, the main feature of Kubernetes is that what makes the master node or what makes the control plane of a master node is it comes with four services. It's called etcd, scheduler, controller, and API server. Um, API server basically exposes the Kubernetes API. It's the front end of the control plane, but most importantly, it manages the authentication and authorization. etcd is more about backing up the cluster data store and make sure you take the backup of the cluster database because rest of the three services can be reinstalled, but if you have a backup you can restore. The format is key pair value. Kubernetes scheduler, it takes care of the automatic scheduling, custom scheduling, especially like affinity and non-affinity rules, resource requirement, placing some policies, um, such as component that watches for newly created pods with no assigned nodes and then select a node to make them run on it. Controller, this is the process which manages the current state and desired state, and if there is any gap, then the API service is notified about it to take the action. So, what does it mean by current state and desired state? So think of it like a thermostat in a room. When you set the temperature, that tells the thermostat about the desired state. The actual room temperature is in the current state. The thermostat acts to bring the current state closer to the desired state by turning equipment on and off. So controller manages the current state toward the desired state. Um, I'll 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 skip rest of the part. It's all theoretical and it's always available on the website, so on the Kubernetes website. But these are the sources where I have made my notes. It's not mine, frankly. The diagram is the master node runs has the four services as you can see: etcd, controller, scheduler, and API service. Now from here it manages the worker nodes, which is actually Docker hosts running the containers. As you can see, it is running container runtime, and you have certain services called kubelet, which is agent which actually is responsible for heartbeat with the API server. So that's how the connection is established. Quickly, yeah. So this is mostly around the intro about all the four services. In the next one, we will start with the installation of Masternode. Thank you.